So I'm Allie. I'm a senior software engineer with AWS, and today I'm going to talk to you about some of the work my team is doing to facilitate automated scale testing of O3DE multiplayer games. So a little about me. I've been with AWS for about 7 years now, and working on O3DE for just over 1. So my phantom co-speaker is Junbo, who's another SDE who's working on O3DE, and has been working on that and its predecessor technologies for over 5 years. Unfortunately, Junbo could not actually be here in person today, but he should be hanging out in the SIG-Network Discord channel in case anyone is in there and has questions or just wants to say hi. So here's a quick look at what we're going to talk about today. So first, we're going to go over what our goals were for testing multiplayer games and introduce the tool that we're building to try to meet those goals. We'll also take a look at some of the major challenges you need to tackle when testing network games. And then we'll dive into how we actually accomplish different parts of our test setup, including building the game for release, instrumenting game metrics we need to track during those tests, and then what AWS resources we're actually deploying our game server and clients onto. And then finally, if we have time, I'll give you a quick demo of what this looks like when it's up and running, and then just recap what we've learned so far. Okay, so my team mostly works on AWS integrations for O3DE. And something we've been wanting to build for a while was an automated way of testing O3DE multiplayer sample. So if you're not familiar with multiplayer sample, it's O3DE's public sample game, which showcases multiplayer functionality. And it has real-world features like projectiles and player spawning and stuff like that. So the reason we wanted to build automated testing for this game was twofold. So one, ad hoc testing of network games can be difficult, as we'll talk about in a minute. And we figured that whatever tooling we build could be useful for folks in the wider O3DE community who want to build and test their own multiplayer games. So building test automation which works for multiplayer sample could be a reasonable starting point for anyone who's building a game around the same multiplayer mechanics. Okay, so back to that first claim. What are some of the reasons that testing network games can be difficult? So first of all, by their very nature, you need more than one machine to test them in a realistic way. So spinning up a client and a server on local host is fine at first, but if you want to scale up the number of players that you actually want to test with, then you need to start hosting it somewhere other than where other people or applications can actually access it. So managing that client-server connection, that's the first challenge. Secondly, we don't just want anyone to connect to it. So if you're testing an unreleased game, it's kind of risky to leave it open to the internet. But at the same time, your playtesters may not all be on the same network. So you need a way to allow trusted connections to your game over the internet. And then speaking of players, asking more than 1 or 2 people at a time to drop what they're doing and be part of a playtest, like when you need to test it, is not necessarily a convenient or easy thing to do. So we're going to need some way, ideally, to automate scaling up the number of clients that are actually interacting with our game. And finally, we just need a way to quantify how our game is actually performing under different loads. So we need a way to get and aggregate metrics from the game itself and the underlying compute during the test. Okay, so with that in mind, let's go back and break down what our tool actually needs to do. So first of all, it's got to build and package the game so it can be run somewhere that's not our local machine. Then it's got to deploy a server and some number of clients somewhere so that they can securely connect to each other. And then once it's set up, we'll have to simulate gameplay, and then finally capture metrics so we have an idea of how it's performing during the test. And then we just have some general goals around making whatever we build easy to use, easy to troubleshoot, and as secure as possible. Okay, so what we've ended up with is something we call multiplayer scaler. It's basically a Python CLI wrapped around a CDK application, which stands for Cloud Development Kit. And the Cloud Development Kit is basically a framework that lets you define your infrastructure as code, and we'll take a look at that code later. And wrapping a CLI around it not only makes it easy for us to run as developers, but it will make it easier to automate down the line as potentially part of a build or test pipeline. So I'm not going to go into a ton of more detail on this diagram because we're going to be diving into specific pieces of it throughout the talk. But you get a general idea of this setup. So we have a game server that's running sort of in a shared network along with some clients. You've got the developer and the playtester who can securely connect to it over the internet. And then we have a separate metric stack where the server is submitting metrics. And then on the right there, you have a snippet of a config file. So how you end up interacting with this as a developer is by authoring a config file with specific values you need to inform the test before it runs. Stuff like where's the game code on the machine and how many clients do you want to create. And so you end up passing this config file to multiplayer scaler when you run it through the command line. And the CLI part of this is actually pretty easy. There's only 3 commands. So you've got build, which builds the game for test. You have deploy, which actually deploys the game, or the server and the clients into AWS. And then you have the clear command, which just tears everything down. Okay, so I've given you a high-level idea of what we've built. I'm going to go over now what the application level changes you need to make to actually get this to work. Okay, so the first step is just building a release version of the game that we can run on a remote machine. So luckily, most of that can be accomplished just by building the install CMake target that's already configured for O3DE projects. But we also need to do a couple other things, like pre-process our assets so they're ready to go on the remote machine, and update our config files, which are, there we go, which update our config files, which are part of the multiplayer sample that we're running it. So if you're familiar with multiplayer sample, how you traditionally run it is by passing it a configuration file that says what is the server host address I need to connect to when I start up. So multiplayer scaler will actually check, like the build step for that, will actually check and make sure that the IP address in that config file is correct before you deploy the game. And where we get that IP address, we'll talk about in a minute. But basically, that's it as far as the actual build. So if you'd like more granular information about how a release build for Windows works, there is public documentation on how to do that. And we didn't really have to do anything different than what's documented there. Okay, so the next application level change we had to make was instrumenting metrics that we wanted to observe while the game is being tested. And again, there's some prior art here that we can actually build upon. So we chose to use the existing AWS metrics gem because it already has a couple things we need. So if you don't know, there's already an AWS metrics gem for O3DE. It includes a metrics request bus that we can invoke programmatically. There's an example over there. And also a CDK application that will stand up metrics gathering resources and a dashboard for us in AWS, which you'll see later in the demo. So on the right is their example call I was talking about. And that's an example of a real call that we're making on tick to report the number of clients that are actually connected to the server at any given time. So this was an important metric for us to have while building all of this out, because we needed a way to know for real like how many clients were connecting to the server. And then this slide is an overview of the architecture of the metrics gem. I'm going to hand wave over a lot of this because it's also documented in the public docs. But mostly I want to point out that we have an API endpoint that is actually the front of our metrics ingestion sort of stack. And then we have an event stream that's actually taking that data from the API endpoint. And then we're using this top real-time analytics stack. So the batch part on the bottom is optional. We don't actually need this for this. But all we really had to do to modify for our particular purposes were 2 pieces of this sort of default setup. And that was the analytics application itself, and then also the dashboard that it informs. And that change was just to add the metrics we wanted to that application so they could be ingested and displayed. Okay, so we've talked about what kind of shape the game itself needs to be in order to deploy and run with multiplayer scaler. So let's talk about how we actually deploy that into AWS, the game. Okay, so we'll start by looking at the server. So far, we have a folder on disk with our built game. We have some stuff in AWS that's running, listening for metrics. But what's the best way to actually run our game server on AWS for this testing scenario? So let's go back and think about what it needs. So it needs to be in a networking environment where it can connect to other applications that are running on AWS, which would be our game clients. We also want some way of directly accessing the server in case something doesn't work. So especially as we're just building this out, like this first iteration, chances are something is going to go wrong or something unexpected will happen, and we'll need to remote in and check out the server at some point to see what's going on. We also just need to be able to connect to it with trusted clients from the internet, like our QA tester or ourselves. And finally, we want whatever we build or deploy just to be as easy as possible, as easy to deploy as possible. Okay, so the first thing we looked at was Amazon GameLift, because this is Amazon's dedicated server hosting service. So GameLift manages, game client and server connections with game sessions and player sessions. It's got a dedicated SDK that you can use to integrate with your game in order to use it. And where it really shines is to helping with server scaling according to load. So as your game gets more players, more resource intensive, it will scale out your game server clusters for you. But the truth is, where we're at right now is very early in building out our game and tooling. And so we're not really ready yet to worry about a fleet of game servers. We really just need to get our heads around the single server, many client test workflow first. So we decided to focus on sort of this basic scenario first for this first iteration, and then worry about coming back to GameLift after we have need for more than one server. So with that in mind, let's take a look at using Amazon EC2 directly. Well, it's pretty easy to deploy to EC2, one server into EC2. You just need one API call. And we can launch it in the VPC with a hard-coded IP address so that our clients that are going to come up in the same VPC know how to access it, which is kind of cheating, but it means that we don't have to go through the trouble of building a whole separate client connection management service before we graduate to Amazon GameLift. And we don't have to change our game code either to get this set up to work. So that's where we ended up. We have a single game server running in Amazon EC2 within a VPC or a virtual private network. So clients can launch into the same VPC and connect to the server at a known IP address. We can directly access the game server through regular Windows Remote Desktop Protocol, which you get by default when you're running Windows on EC2. QA tester can access the server over the internet because we can configure the security group, which is really just a set of firewall rules around the server to identify them by their IP address and allow their connections but block everybody else. And deployment is easy because we can use the CDK and also EC2 Image Builder to actually package our game assets and deploy them as an Amazon machine image, which is the form it needs to be in order to run on EC2. Okay, so here's a diagram of the server setup. So we've got our game server running on EC2. It's in a VPC with a security group that has rules which allow connections from our developer and our QA tester, but nobody else. And it's submitting metrics to the metric stack we talked about earlier. Okay, so we've got a server now. How should we actually run the clients? Well, they need to be able to connect to the server that's within our VPC. And we still want them to be easy to deploy. But unlike the server, we want to be able to easily scale up how many copies of these are actually running so that we can test our game under different numbers of players. And we don't need necessarily as much direct access to every individual client as we do for the server. So we probably want some basic observability and some logs in case something goes wrong. But our QA testers, for example, they don't need to connect to these clients. And then the server, or I should say the clients, are not actually where a lot of the interesting stuff is happening. It's not where a lot of the bottlenecks are happening. Because as the number of player connections and the number of network entities go up, it's really on the server where things start to break and get interesting. So we decided that, at least for now, we didn't really need to build in as much direct access to every individual client that we were going to run. Okay, so thinking about where to run them, let's start with Amazon EC2 because that's where we landed with our server, right? So running clients on EC2 would mean that we could deploy them in the same way. We could lock them down in the same way. But if we don't need as much direct access and we want to run potentially many copies of this game client, then we should probably start looking at services that will manage scaling, multiple copies of this application out as we need, possibly at the expense of more sort of full remote access to every individual client. So with that in mind, containers are really good for scaling out applications. So containers, if you're not familiar with them, are a kind of lightweight virtualization, which packages an application up together with everything it needs to run. But unlike a virtual machine, which you would run in EC2, it doesn't really include the operating system like within that encapsulation. So the containers themselves are less resource intense, and also because of that, your application can typically scale in and out much faster. And we can also leverage them in a serverless way, which just means that AWS will manage the underlying compute for you. So that's what we've ended up with. We have the clients running in Amazon Elastic Container Service with AWS Fargate, which is the serverless container engine on AWS. So going back to what our requirements were, clients can still run and connect to the server within the same VPC. And deployment is just as easy because we can still use the CDK and then use Docker, much like we did for EC2 Image Builder, to actually build the container image and deploy that. And then scaling is easy because our ECS service can easily scale up to even like hundreds of clients, which is probably more than we need right away. And then in addition to that, we don't get remote desktop access like we had for the server, but it is easy to send client logs and metrics to Amazon CloudWatch. So we still get some observability from the client. The clients, multiple. Okay, and then this slide might not mean much to folks who are not familiar with containers. Can I actually really quickly see, is anybody in here familiar with containers? Has used them before? Okay, nobody. So this is a Dockerfile, which is basically instructions for building a container. And all I really wanted to show is how relatively simple it is. So basically start with a Microsoft Server Core base image, and then you install the C++ redistributable package on that, which you need, I think, to run any O3DE game in a Windows environment. And then you copy the project, which is the game like itself, into the file system of the container, and that's it. So this is really just to show that building this container image is only a couple of steps. Okay, so like before, here's a diagram of the client piece. So you can see we've still got our server running, but now we have this ECS service, which is going to run as many copies of our game client as we want in the same VPC as the server. Okay, so I think I've talked enough about all the individual pieces of this. Let me show you how it looks for real. Okay, so the first thing I want to show you is multiplayer scaler itself. So here is a full version of that config file I was talking about. And the first, say, half of these values, and these might be hard to see, so let me try to open them up. Okay, a little bit of overlap, but that's okay. So like the first half of these values are needed for the build portion of this. So it's information about like what kind of build do I want to run, where is the engine source code on my machine, where is the path to the actual project I want to build and deploy, stuff like that. And then the second half of these values are needed for the deployment itself. So you have the client count, which is how many copies of the game client do I actually want to run. You've got the private server IP address. So this is the IP address at which the server will appear within its private network. So this is where the clients are going to try to talk to it. And then you have information like, what's my AWS account, where should it go, and then in what region should I deploy this? All right, and then after the deployment portion of this, what you end up with, using the CDK, is a couple of CloudFormation stacks. So the Cloud Development Kit basically take the infrastructure you defined as code and sort of compile it down into CloudFormation stacks, which is AWS's sort of infrastructure as code primitive. So the stacks you end up with, you have the CDK toolkit, which is not very interesting. This is just like anybody who uses the CDK ends up with some resources to manage the metadata for that, basically. And then we have our metrics stack, which manages the metrics gathering resources and also our dashboard. So if we can take a look at that real quick. Oh, and you can see we had 3 clients running, but now we have 2. So this dashboard isn't super elaborate yet, but we do have important things like, are we actually ingesting, data from our metrics endpoint, at what rate? And then we have important events like, did a client leave the connect, like there was a client connection severed, or did they leave? And so we see there was at least 1 in the near future, or in the near past. And then we can see that reflected here as well. So we had this real-time client connection count of 3, and then a client left and it went down to 2. Okay, so that's the dashboard. So then we have the common stack. This is just the shared networking environment for the client and the server. There's not anything very visually interesting for me to show here. But then if we go to the server stack is what's actually standing up our game server and all the resources that it needs to run that. So I can show you that here is the server just running in the EC2 console. So hooray, it's running. It has a public IP address. It has a private IP address. So the public one, we're going to access it like as a QA tester. And the private one is where the clients running at AWS are going to access it. Again, this isn't super visually interesting, but what I can do is show you, there we go, what it looks like when I'm remoted into that game server. So here I am. I'm actually remoted into the game server that we deployed with this. And you can see if I have the task manager open, that we have the server launcher running as a background process on this machine. And then when this AMI, or this machine image, was deployed, it was deployed with this O3DE folder, which contains all of the code and necessary dependencies for our game. And then we can take a look at the server log as well. Come on, I don't want to rename it. There we go. Okay, and so here's the server log where the running server is sort of outputting its activity. And so we can see stuff like, okay, it's running with a null renderer, which makes sense because it's a server. There's nobody like on the machine to see it. We've got this new incoming connection from a 10 fronted IP address. So that's one of our clients that's running in ECS. We've got this other client, same thing. And then you see these connection failed due to stream error from some external IP address. This was me. I was trying to connect to it, but failing. So after over the last couple of days. I am blaming this, or starting to blame this, on the hotel Wi-Fi because this was working spectacularly on Friday. But this is a real world example of why having direct access to this is helpful, because now I can see like, oh, my client actually like reached the server at least this far to start a connection, and then there was a stream error and it got cut off. Okay, so that's the server itself. So the last thing I want to show you in terms of stacks is the client stack. And I won't go through all the different pieces of it, but there aren't actually that many. The main takeaway is that we have an ECS service that's running right now 2 copies of our game client. And so if we go to ECS, you can see here we have ECS calls any application that it has to maintain multiple copies of, a service. So here we have the service for the multiplayer sample client stack. We can see that we wanted 2 to be running, and we have 2 running, so that's great. And if we go into, let's see, just one of these tasks, and we check a look at the logs. A task is like a single instantiation of a game client. And there won't be any logs for the last little while, because I've had this running for a little bit. But we should be able to see something interesting. Okay, so here's, no, I have to go back 1 week, that's so far. There we go, okay. So this is, these are logs the client is producing as it's sort of booting up. And we can see, where is it, the client or the server connection? There we go. So this is actually where it connects to, you can see 10.0.0.4, which is our game server. And we can see that right from the AWS console, which I think is cool. Okay, and then the final thing that I wanted to show you is what this actually looks like when you're connected to it locally. So like I said, I was having some struggles actually getting this to work with the hotel Wi-Fi situation, but luckily I did sort of record what this looks like. So here I am. I'm connected to my game server that's running, and you can see there are 2 other players in there with me. But they're not real people. They are our clients that are running in ECS. And then I'm going to hit some blocks, because why not? But yeah, and you can see in the bottom right, there's a very small IP address. That's the public IP address for the game server that I'm actually connected to during this player session. Okay, so that is it for the demo. Okay, so to close things off, I want to revisit those network game challenges I brought up earlier and talk about how we ended up addressing them, at least in this first iteration of our test tooling. So client connections to the server, we got those working by running our server and clients in the same network in AWS with a predictable IP address so that the clients could discover the server. And our playtesters and developers can securely connect to the server because we've configured the firewall rules to recognize them but to block others. We can also scale out how many game clients are hitting our server at any given time because we're using an ECS service. And then we're getting metrics from the game server by using the AWS metrics gem. And that includes some useful visualizations that we can get from CloudWatch. So before I leave today, I did want to talk about a couple things that we've run into since we first built this, and maybe some planned improvements for future iterations of it. So the first thing is that deployment with EC2 Image Builder has been easy, but not quite as responsive, I think, as we need for this kind of tool. So a big part of this is because when you use EC2 Image Builder, there is a mandatory test phase where it's sort of baking your image, and then it deploys a test version of it, make sure it's OK, and then it tears it back down. And so if you're deploying into production, this is really important because you don't want a non-hardened AMI to go in and replace all the instances in your cluster. But for us, this whole setup is part of a test workflow. So it'd really be better if we could get that up and running more quickly because the stakes aren't quite as high if it's not a perfect machine image. So I'd like to make that deployment more quick if we could. We also discovered that hard coding the IP address, remember I said this was kind of a cheat, means you can't actually do in-place updates. So if I wanted to rebuild my game and deploy an updated version of my server while there was already one running, I can't do that because the IP address I want to deploy to is already taken up within that network. So right now we have to tear down the server stack before redeploying it, which isn't terrible, but kind of annoying. So I would like to make that better. Possibly by tagging the container instance and then having the clients actually query for it by tag when they start up. So we don't have to actually hard code anything anywhere. It's also worth noting that Windows container images, which is what we're building for the game clients, are actually quite large. So most of that is the Windows base image itself. So the Windows base images you need just to even build a container image are pretty hefty themselves. So server core, which we're using, runs about 6 gigabytes, and that's just to get started. So building in Linux support for the clients, I think will make a big difference and let us make those game clients, even more compact. And finally, like I mentioned, we'd really like to be running this on GameLift, so that is something we're actively working on. OK, so if you're interested in following along with our efforts to automate testing of O3DE multiplayer sample, please keep an eye out on the SIG-Network Discord channel. So there is my username on Discord, and then also Jinbo's. I'd be happy to take your questions. We're in there frequently, either now or in the future. And you can also check out the AWS metrics gem in the public docs if that struck you as something that might be useful to you. And then finally, if you want to try out something like this for yourself, we have 2 things I want to let you know about. So the first is that we have support for EC2 credentials actually available right now in the development branch of O3DE. So this is a feature that makes it a lot easier to actually run your O3DE projects in EC2 because you don't have to go through credential setup separately. You can leverage the credentials that are available for you within that AWS environment. So that's available now in the development branch. And then coming soon, we're going to be open sourcing the entire source code for multiplayer sample. Multiplayer scaler, multiplayer sample, already open source. Multiplayer scaler is coming in terms of open source code. I was hoping that would be available today. We're going through the last little couple approvals we need to actually get it out. But very soon, we'll be able to offer this entire tool in its source completeness to anybody else who would like to either try it out or modify it for their own sort of purposes. But that is it. So if anybody has any questions, I'm going to step away, but I'm happy to talk to anyone after who would like to. So thanks.